So now for this circuit, we have to find I naught of t, and this circuit has two current sources, a 7 amp step input and a 5 amp step input. So in order to analyze this circuit, we're going to use superposition. So the first thing we have to do is convert the circuit into the Laplace domain. So remember, the impedance of a resistor is just its resistance. So this stays 1 ohm. Can't forget our sought variable, which is now I naught bar of S. Our 7 farad capacitor will be 1 over 7S ohms. 4 ohm resistor stays 4 ohms. Our 6 Henry inductor becomes 6S ohms. And then our sources are just step inputs. So just 7 over S amps, and then 5 over S amps. Okay, so now we can simplify just a little bit. We have these two, the capacitor and the 1 ohm resistor are in series, so we can combine their impedances by just adding them together. So I'll just make that change on the same diagram. So that'll just be 1 ohm plus 1 over 7S ohms, which is equivalent to 7S ohms plus 1 all over 7S. Well, I don't know why I did that. 7S plus 1 all over 7S all ohms. So then combining the capacitor and the resistor, capacitor impedance is replaced by short, and combine them into a general impedance, the value of 7S plus 1 over 7S ohms. And that's all the simplifying we can do. This impedance is in parallel with the inductor. However, because they are in parallel, they do not have the same current. Since we are looking for the current in this branch, if we combine the two elements, the sought variable would be gone. So we can't combine those elements. So now we can go on with superposition. We'll start by killing the 5 over S amp source. So I'll redraw the circuit. Okay, so now we have the circuit with the 5 over S amp source replaced by an open circuit. Our sought variable, I naught bar of S, and since we've changed the circuit, this is going to be I naught prime of S. Okay, and then now we can simplify this circuit by combining the 4 ohm resistor with the 6S ohm inductor. so just adding these two impedances, it's just 6s plus 4 ohms. And again, circuit tutor will want you to write it as 2 times 3s plus 2 ohms. And now we just have a simple current divider. So we can use the current divider formula, find our slot variable I naught prime. Now the current produced by this source is flowing the opposite direction of the slot variable, so it's going to be negative 7 over S amps times, and then since we're looking for the current through this impedance, we're going to put this impedance on the top. The ohms all cancel out. We're left with amps. And then simplifying this equation, I'm going to skip a few steps here. So we have negative 2.33 times 3s plus 2, and then we get a polynomial in the denominator, which again we can use the quadratic formula to solve, so I'm just going to give the factored version here already, and that is s plus 0.0296 times s plus 0.8037 amps. If you want to just verify, go through all the steps, make sure you get the same answer, because on the exam you will have to show all of your steps. So anyway, this is our I naught prime of S. So now we can go back to our original circuit, and we can kill the 7 over S amp source. And again, we'll replace that 7 over S amp current source by an open circuit. This impedance, 7s plus 1 over 7s ohms. This resistor is 4 ohms. Current source is 5 over S amps, and then our 6s ohms inductor. Okay, now, and then of course, our sought variable, which is now, in this case, I naught double prime. And now we can do a similar thing, just combine the 4 ohm resistor with the 7s plus 1 over 7s ohm impedance, because they're in series. And doing that gives a combined impedance of 35 S plus 1 over 7S ohms. We can redraw the circuit. There'll again be another current divider. So we have our 5 over S amp current source pointing down, our sought variable, which is defined as pointing up, I naught double prime, our combined impedance 35S plus 1 over 7S, and then our inductor 6S ohms. So now again, you can just use the current divider formula. I apologize if this is cut off on the side here. Sorry, current divider, I naught double prime S. Now, the current produced by this source is pointing the same direction as the sought variable, so it'll be positive this time. 5 over S amps times, and then we'll have, since we're looking for the current through this impedance, we'll put this impedance in the numerator, so 6S ohms plus, or over 6S ohms plus 35S plus 1 over 7S. Ohms cancel out, you're left with amps. And then simplifying this equation, skipping a few steps again. I naught double prime of S, it's going to be equal to 5S. Then we end up with the same denominator as we did with I naught prime. It's going to be S plus 0.0296 times S plus 0.8037. So now we have our I naught prime and our I naught double prime from using superposition. Now we can add those two together to get our sought variable I naught bar of S from the original Laplace circuit. Okay, so using superposition, we found I naught prime to be negative 2.33 times 3S plus 2 over S plus 0.0296 times S plus 0.8037, that is in amps, and then I naught double prime to be 5S over the same denominator, also in amps. So now we need to focus on finding our sought variable, I naught bar of S, and then taking the inverse Laplace transform of that so that we can find I naught of T. So first, we'll find I naught bar of S, which is just going to be the sum of these two. Since they have the same denominator, just add them. S plus 0.0296, S plus 0.0837, oops, 0.8037. And then if you expand this part and then add the two terms in the numerator, it comes out to be negative 2S plus 4.67 over the denominator, of course. And that is amps. Okay, so this is our equation for I naught bar of S. Now we need to find the partial fraction expansion so that we can take the inverse Laplace transform. So say that this is equal to K1 over S plus 0.0296 plus K2 over S plus 0.8037. Okay. Using the same method as for the previous video, we'll find K1 by multiplying the entire equation by the factor S plus 0.0296, so we can get K without a denominator, K1 rather. And then when this multiplies with that, it cancels out this factor. So then, and then we'll set S to be equal to negative 0.0296 so that it becomes 0 and eliminates K2. So then we're going to be left with negative 2, and then S again is set as negative 0.0296 plus 1.67 over, and then it's just going to be negative 0.0296 plus 8 plus 0.8037. Yes, negative 0.0296 plus 0.8037. That's in amps. And then solving that just comes out to be negative 5.956 amps. So again, I went into that process a little bit more in depth in the previous video. I'm just going to skip over that for K2. It's just the same process, and that's just going to give K2 as 3.956 amps. So now we can plug those back in to our equation to get our final partial fraction expansion. So that is I naught bar S equals negative 5.956 over S plus 0.0296 amps plus 3.956 over S plus 0.8037 amps. So now we can just take the inverse Laplace of this, and that'll give us our final answer for I naught of t. Both of these are in the form in the table for the exponential, similar to the previous problem. So it's pretty simple, just going to be negative 5.956. Well, I'll put brackets around the whole thing. Negative 5.956 times e to the negative 0.0296 of t plus 3.956 times e to the negative 0.8037 t. Close the bracket, and then that is all multiplied by the unit step function u of t, and it's all in units of amps. So there's our final answer. I naught of t equals negative 5.956 times e to the negative 0.0296 t plus 3.956 e to the negative 0.8037 t, all multiplied by the unit step function.